That's weird. I could have
All
sworn I
right.
pressed it. Whatever.
All right, we can start all over again.
No,
You,
no, not at all. We keep pushing forward.
all right.
Um, so I was gonna say, I'm at the point right now where like I'm trying to figure out like what this architecture is supposed to be, and if you're aware of any books that I could buy that pretty much, because I haven't found any books that are specific to, or books that are dedicated to event sourcing. I found books that have a chapter on event sourcing, but I don't have
Okay.
any type of like Bible for event sourcing. And so
Mm,
what I'm looking at right now is like, um, maybe do I have the shopping cart app up? Yeah, I do. So what I'm looking at now is how many different data stores or how many different types of data stores do I need if I'm doing event sourcing
mm.
with an e-commerce app? And what I mean by that is if I share my screen,
Yeah.
share my screen, hide that,
Okay.
and the speech delivery is building, so that should build sooner or later. And
Mm-hmm.
before I hit broadcast, I thought I was already recording, and I had a conversation with you about, do you ever find yourself being narcissistic when you
Mm,
just fall in love with the code that you write, and you're like, yo, I wrote this. Like,
mm.
I find myself talking to my girlfriend a lot while she's talking about nothing. I praise myself as I'm programming without while she's trying to talk to me. Hold up for one
Mm.
second. So it should launch now, and what I want to show you is this is kind of like new to me,
Mhm.
and you'll see exactly what I talk about because I don't think it'll I don't think it will be clear if I try to talk to you without showing an example.
Okay.
I didn't know you had children.
Me? No,
Yeah.
I don't.
I hear children in the background. All right, so
Yeah. All right.
I want to put event store on my resume. Okay.
Okay.
Um, but like, throw some other items on here. But I just had a revelation that that when you load in observable information
Mm-hmm.
for a user to select from, that's
Mm-hmm.
not a user generated event. It's just data. Like you have to seed the application with data that the user can observe and then interact with.
Mm-hmm.
And are you following me so far?
Yeah, I get you.
And so I just had this revelation that this event store that I wanted to use so I could put event sourcing on my resume and start applying for a different category of jobs outside of just being a mobile app developer or a desktop developer. It
Mm-hmm.
just dawned on me that more than likely you're managing multiple databases if you're doing event sourcing, and it's not just one single database.
Mm-hmm.
Hence, your data store.
Yeah.
It's still potentially some SQL database to just load in data like the offerings for restaurants and menus and stuff like
Mm-hmm.
that because those
Mm-hmm.
aren't events.
Mm-hmm.
It, am I right, or is there something I didn't consider where you could still
You
have
are,
one data store that solves all problems?
you are, no, no, no. You're absolutely right. You can't just use event stores uh, in and of themselves because they aren't really they they are designed for something very specific, right? So they are designed for events. In other words, changes in your system. Okay. Now, what most of the architectures I've seen, they have an event store and they still have a cold, what they call a cold store, if you will, right? So the idea is that the event store is the source of truth, but the cold store is where you know about command query separation now, obviously. So
I'm
your
familiar at a high
commands,
level, yes.
okay, so it just says that in any system, right, you have two kinds of interactions that can happen. You have your commands and you have your queries, right? So your commands are things that alter state, okay? That alter the state of the system. They cause some kind of change. They have side effects. Those are commands. Your queries, on the other hand, don't have any side effects whatsoever on the system. They are just like a window into what is in the system at any given point in time, okay? And that's where the idea of eventual consistency comes into play. So the eventual consistency principle is saying that your commands, right, as your commands are sent, right, the queries don't have to be in sync with the commands. So say, for example, I delete an item. You don't have to, in other words, the next time you query for that item, it may still be there. But the rule is that the whole system will become eventually consistent, meaning that eventually the item will vanish. Okay, you've seen that with Facebook a lot, where maybe you try to comment on a post and you click send and it looks as if nothing has happened, and only for you to try sending again, and next time you now see that there are two comments of the same type, right? Meaning that the first one actually went through. Yes, that is eventual consistency at play. So what people do with event stores is that by having that separation, all the commands go to the event store, and then all the queries go to the code store directly.
But there's, well, not, I'm not challenging you, but
yeah, sure.
In a way, I kind of am. Not all of the queries, because you still want to replay the commands to get back to a specific state of the system.
Yes and no.
Okay.
Yes, in the sense that if you need to, you can go ahead and do it. But no, in the sense that it is very inefficient to replay all the commands to replay all the commands to get to the current state, especially if you just want to see that state, right? So for like simple applications, it will fly, right? You can just go to your event store and just go through the whole, just aggregate all the events and find out what the current state is. There's no big deal there. But where it starts to get really hairy is like if you start to grow, if you are big enough size, right? You will get to a point where that is so inefficient that your system will just grind to a halt. Okay. Instead, what should happen is there should be you should have a window into your what do they call it?
Snapshot.
Code. Yes, your code store or your snapshots, right? With the idea that if anything were to happen to that your code store, because the event store is the source of truth, then you can just replay all your events and then get the current state and then update your snapshots database. Does that make sense?
The snapshot goes in a code store?
Yes, it does.
Oh.
Yeah. So when you are querying against the code store. But when you are making updates to your system, when you're sending commands, it goes to the event store. The event store is the source of truth, not the code store. The code store is just there to pipe all the reads to your system, right? So anytime somebody just wants to, like what you said, okay, I just want to see how many products I have, I just want to display the total count or whatever the case may be, those queries are going to the code store. But the event to say I have added a new order, or I have made a purchase, or I have added more to the inventory, that has to go through the command, and then some back-end processing system would now update the code store. Does that make sense?
It makes sense. It just feels weird to me, because that means that every event is going to be written to the code store.
Yes, that is correct. But the code store is just there to represent the state, in quotes, of the system. So if you remember using something like Akka, or it's a very popular pattern where you have like some kind of inbox, and that inbox acts as your event store. So as events are entering into the inbox, they are just like piling up essentially. Then inside of the actor, you have a state, which could be a value or whatever. That state is the code store, in quotes. And then anytime you sent a a query that goes to the cold store and retrieves the current state that you are seeing. And then as the events keep being processing, that state gets updated. But if at any point in time the state, gets corrupted, or you need to wipe that state, it's no big deal. All you just need to do is replay all the commands that you have sent before, and you will get back to the exact state where you are in. It's kind of like database migrations, because database migrations is exactly the same pattern, just played out differently. So in a database migration, right, your database has a zero state where there is absolutely nothing in your DB. And then you create migrations, and those migrations are like commands in quotes, and they stack on top of each other, right? And then the database, but for every command for every migration that gets created, your database gets updated to the new state. And if anything were to happen to the structure of your DB, or you wanted to go back to any particular DB, a state of the DB, you can just kill the database and then replay all your migrations, and you are back to the exact structure that you are supposed to be at. The added advantage, as you can imagine, is if you have multiple data stores, right? Then, or if you had multiple data stores, or if you had multiple systems that were all somehow connected to the same amount of data, all they would need to do is to figure out what was the last command that was run against them, and figure out what commands entered into the system, and just play those, so that everybody can now get on the same page in terms of what the state of the world is. But they can do that at their own pace, as opposed to having one file that everybody locks on, something like that.
You should write a book, man. Something else that I've been wondering about is if I should. I'm not even sure what the formal name is. If I should do push or pulls when messages. Well, for the messaging system, if I should go push or pull. So, translated,
okay.
User add some items, remove some items. I might write to eventually I'll write to the database for that stuff, so that I can measure difference in behavior and make more informed decisions to maximize profit. But when a user checks out and they request a delivery, the options are that I have some message queue, and I have some process that checks periodically. I don't know, every 15 seconds, every 30 seconds, whatever, to see if there's an order request waiting. Is there an order request waiting? Is there an order request waiting? Oh, there's an order request waiting. Consume, process. And I think the advantage with that, because I read the book Release It. Have you read Release It?
No, I haven't.
Okay. Using that strategy of providing a queue and periodic checks to pull messages off the queue, I think the argument is, or the advantage is, that you can throttle your system and you won't overload it. I mean, you may run out of storage memory, but you're working at a sustainable pace of pulling messages off. But the other strategy, so that was like a pull, but the other strategy was like a push. And this is like using ASP.NET's, what's that tool that they use for like messaging and stuff, like sending a message, typing a message back, like chat room.
Signal
R. So I was considering, like, okay, when someone has their phone out and they order a delivery, just like I'm on Uber and I order a ride, I want to see the potential people that can satisfy, or the various people that can satisfy my request show up on the map, and then whoever accepts that request, and then a route that gets drawn on the map of where they are and the route that they're taking to deliver me my request. If someone from a user's point of view that's holding the application, it doesn't make sense for me to make them wait 15 seconds max just to trigger if someone can satisfy their request, meaning that they have to hold their after they hit the order food on their phone. Potentially, nothing will happen for 15 seconds until some process gets triggered and checks to see if the queue has any items in it. So it's kind of like the user experience will take a hit, or I don't have this problem right now, which I think now, since I discussed it, I have the answer. If it was a very busy back-end system, then I'm risking performance, right? But in this case, there probably won't be more than 5 or 10 people to even download it, let alone discover the app. So I think I answered my question.
Okay. No, so
what your thoughts are. But you understand what I'm saying, right? Do I do push or pull?
Yes, I do.
At the expense of user experience versus a very controlled system that isn't going to have any type of serious performance issues?
Okay. So the answer to me is quite simple. So it depends on how important each operation is. So for example, if I try to order an Uber, and it happens, right, where you try to order a cab, it tells you, oh, okay, we've picked a particular ride for you, and all of a sudden it just trips off, and it's no big deal, I can easily try again, right? But it is a lot more dangerous if it's a financial transaction, or if I'm ordering something, or you get what I'm saying, because in those cases each message or each command is super important. So if I'm Amazon, for example, every order I lose is money that I've thrown away. If I'm a bank, every transfer that I don't fulfill is money that I've lost, essentially. That's the first aspect of it. The second aspect of it is, do I need immediate feedback, right? So for you kind of alluded to this yourself. So if I'm ordering things online, right, immediate feedback is not so much important, right? I don't mind getting an email later saying you've processed your order. The same thing with a bank transfer. Even though in a bank transfer, you want it to be as quick as possible, but immediate feedback is more paramount, right? So those are the two situations where you have to use a pull system, right? The e-commerce and the banking that I gave an example of. Whereas for the push system, right, you can do that for things that, it doesn't really matter if what is more important is immediate feedback and not necessarily accuracy or reliability per se. And the truth is, you can mix both, right? So an example of mixing both is you could have an API that when you call the API, it would not return until a result message comes out of your system. So let me explain what that is. So let's take the event source approach, right? What could happen is you could have some kind of API. When you call the API and say, I'm trying to book a ride, right? That would send a message into your system saying XYZ person is trying to book a ride. And then it would wait and keep querying the code store, maybe every 2 seconds or 3 seconds until it got a response back, right? Saying that, okay, yes, the ride has been triggered and this is the information of the ride. And then it would now notify the caller, right? In fact, that's the whole point of this error code 204. When you call certain APIs, you don't have to return 200, you can return 204. And 204 has in the header like the URL that you should call back, essentially, to know when your request has fully processed and the information of the ride, if you will. So you would call like Uber API. Let's assume you called Uber API and said, I want to book a ride from so place to so place. Then Uber would return a 204 with the ID of the ride, right? But when you queried that ID of the ride immediately, to tell you something like ride is in process or in progress, or your ride is currently we're selecting ride. We're looking for the closest person near to you, something like that. and only when the ride has been fulfilled in the back end will the UI just light up essentially. And you can imagine in some cases, if there is very busy traffic, that we are looking for rides for you could take 5 minutes or 10 minutes or whatever the case may be. I don't know if I'm making any sense. So you could mix them, right? But in practice, that is if you are maybe at Uber's scale. But in practice, I think those kind of situations, you just use, you just, what's the word now? You just use a push system like Signal or whatever, and you're good to go. You shouldn't have any problems. In a very powerful way, I would suggest that to solve that problem, you should use some kind of actor system, because actor systems have this whole concept that I just described to you built in, and they are more real time. So you don't have the overhead of putting stuff on the queue or in some kind of database and retrieving it from the database later. All those things will happen in memory. So you get far more performance, and you still get to have this, should I say, scalable CQRS event store kind of system. In fact, Akka has this concept of an ask method, right? So the ask method is where you could just ask an actor, I want to book a ride, and it would reply synchronously immediately. And the way they do it is behind the scenes, they do exactly what I just described to you. They wait, send a message to the system, and they hold that thread until they get a returning message, like a reply essentially. Then they can now, reply. And if a particular timeout expires, they will just say, well, we timed out, we could not fulfill the request or something like that. So, yeah. So many ideas.
Yeah, the other part was I think an advantage with a pull type system is like durable messages, like, or message guarantee. Like there's certain message queue technologies or libraries where that message is guaranteed to get processed whenever it finally does come online or whatever. It's kind of hazy, my understanding of it, but yeah, I just want to get this stuff on my resume and be able to talk knowledge, be able to be knowledgeable about it enough that I could really open up more opportunities. Because right now, just doing desktop development or mobile development, it's too many people that are self-declared programmers. It is. And like, I'm struggling to maintain the same hourly rate. And I mean, you just look at, YouTube all these different conferences, and they're all talking about microservices and cloud computing. And I just feel like in order to like maintain the rate that I believe I should be making, I just got to bite the bullet and really operate at a higher level of like systems, plural, versus just a client device.
Of course.
So I just got to get this proof of concept done, potentially have a little business operating down here off of it, and then give a talk, and then hopefully that could open up some more opportunities where I could finally start getting like $130 an hour or something.
I think what you need to do is most of these things I learned them from experience, right? So even though I've read about a lot of this stuff, it wasn't until I actually built a system, and when you see like what you built clog up because of the architectural decisions you've made, and then things will click a lot better when you've been able to try multiple approaches to solving maybe some kind of scaling problem. And then, with that, you start to get a good sense of, okay, this will work. This I shouldn't try. This I can manage. So, for example, one of the things that I learned the hard way with Signal R is that Signal R doesn't scale linearly. So Signal scales up to a particular point, and after that, it just breaks down. So in order to scale it beyond that point, you need to essentially rework everything. So, for example, if you build a simple Signal R client, right, you are taught, okay, you have this hub on the server, then you have a client, and then the client can just send messages to the server, and the server can send messages back to the client, right? No big deal. Very simple. That works until you start getting to, I don't know, maybe 10,000, 100,000 concurrent connections. And then you now notice that your server starts to break down. So now, in order to scale it horizontally, you can't just create multiple instances of your server because those servers will not share state between them. So, for example, I could have something in my shopping cart, and the next time a message is sent, if it hits a different server, my shopping cart will come back empty or come back with a different set of items from the other previous items. So now you've shifted the problem one step forward. Now you have to now synchronize your shopping cart um, across multiple instances of the server. And that's something called a backplane, something that sits behind Signal R that coordinates communication between all of them. And the official way that Microsoft tells you, okay, this is how you should do it. It used to be that you would install some kind of Redis, they call it a backplane. You could install either Redis or SQL Server. So what that would do is to essentially be like your reliable message store. So it's it to be storing all the messages as they are flying in and just keeping track of and distributing, not really distributing them, but the other servers can be querying that database to see what new messages have come in and now, handle that, whatever. So that was the official way of doing it before, but even that was so painful. So recently, Microsoft came up with this their Azure Signal R service. I don't know if you know about it on Azure.
No.
Okay, so yeah, the Signal R service is where they've done all that madness for you. So yours is just to connect to that Signal R service, and they can scale almost infinitely if you wanted, which is a good idea. It's just that you are now like leveraging Microsoft's expertise. If you were to go somewhere where they told you, oh, we don't use Azure here, or this has to be on-prem, then you're stuck.
Yeah, I mean, I was going to ask, like, well, isn't there a cloud solution that scales that for you behind the scenes? And you pretty much said it already.
Yeah, yeah. So what people do, well, the last time I worked on such a problem, my solution was just to use Akka.net behind behind the Signal R servers. So by connecting Signal R with Akka.net, you get this. Akka.net now acts as your backplane. So the state is stored in one Akka cluster, and then anytime a message hits the actor or whatever, the actor would broadcast to all servers. Okay, so that whatever clients are connected to each of the servers, they would also get the message that, oh, my state has changed or something like that. But at that point, this is really advanced stuff. But the main idea here is that I think you should do is try it out, whatever your architecture is, try it out, let people start using it, and just do a lot of monitoring, right? So that will help you to get a sense of, okay, I need to change my approach, or this approach works really well and this approach doesn't work at all.
You know what I'm scared of? Like, I know that it's in my best interest to write to a cloud storage, whether it's Azure. I mean, it's going to be Azure, right?
Yeah, sure.
But I'm very into tests. Like I'm very passionate about tests, and I don't think it's a healthy combination of doing SDET type stuff or software development engineering tests, writing all these integration tests, and having property tests that hit the database, and then getting your Azure bill.
Oh, okay.
So that's the part where, like, yeah, the system that I'm building, and this is like my hobby project as I'm still looking for my next contract. The system that I'm building is going to be doing like financial transactions, right? There's going to be payment gateways and hence the reason why I chose like event sourcing as a architecture or architectural strategy is because like there needs to be some type of audit trail, so that I can save myself. But it's really important that I test the hell out of it. But I don't think integration testing and really pounding all the different permutations, if I could even use that as a word, I just think that's going to result in like a $500, $1,000, $2,000 bill.
No. I think you are. I think you're conflating the two things, right? So you have not that you're conflating, but I think the problem is different, right? So the real problem is, can I have a version of my entire solution that is currently running in production locally on my machine? So that should be your goal, to have two completely separate environments that don't mix, right? So that way you would run all your integration tests on your local machine the way you're already doing it. So your database, your event stores, and all of that should have a form of copy that you can run locally. And thankfully, Azure has that actually. They have this Azure Storage Emulator. It's an app, you install it locally, and then you can connect to it as though you're connecting to an Azure instance. That way you don't get a $2,000 bill, because what you want essentially is you don't want to test or develop against a cloud instance almost in general. You get what I mean?
Does that not go contrary to the point of QA? Like, you want to test essentially a copy of production. You want to be as close to production as possible. But it's like, no, you don't want to test anything that models a production-like environment, because you're going to get a production-like bill based on the type of resilience engineering that you may be trying to execute or implement in regards to QA. So I get what you're saying. It's just the other part is, the way that I was taught or trained is, you want to model production as you're testing. Like, you want to get as close to the production-like environment as possible.
But I think, okay, so there are two things in play here. First is that, yes, it makes a lot of sense to try to model production as much as you can, but in my experience, nothing beats production. Absolutely nothing beats production, because what happens in production is that, because you can never have, by definition, you can never have the kind of load, okay, that you get in production in your staging or in your QA environment. You could simulate it, but it is never like production, because users are weird. Users will do weird things. In fact, one of the things that surprised me when I first started deploying apps to production was that I would look at the traffic and I would notice that I keep getting all these people who just ping your IP address for no reason. People who just hit your URLs for no reason. In fact, Google, Microsoft, all the search engines, right? They hit your page for no reason. They just hit your page and try to get things out of it. So the kind of load you see in production, you can't really see it anywhere else. So I don't even bother trying to replicate production in terms of the load, right? Instead, what I try to do is to have as much of that production configuration as templatized as possible. In other words, let production just be a configuration essentially, that I can just use and apply that configuration. And that's one of the things that tools like Kubernetes does very, very well, because with Kubernetes, right, you can get what you have in production is literally what you're running on your machine. There's absolutely no difference whatsoever, right? The only difference is that you have an instance of what's on your machine running in some cluster somewhere. And if you decide that you don't want to use Amazon anymore and you want to move your production to another cloud provider, you just go nuke it and just set it up somewhere else, because your production is essentially just a configuration file, right? So yeah.
Have you had the opportunity to practice resilience engineering or chaos engineering?
No,
My
no.
thought
So
my thought process is to periodically, maybe it's like every, maybe like every 15 minutes, or maybe every hour, or maybe twice a day, whatever.
mm,
Um, create a bot that will perform some type of transaction, um, for a happy path, but also various combinations of sad paths that should never get through, as long as that bot provides some type of tag, so that when it comes to like the payment gateway of the system, or
mm,
any other mission critical parts of the system,
okay.
that it can identify somehow that this is just a bot and this can be ignored, but we'll just mock what it would be like, but we're not going to actually process this with the actual payment API.
Mm,
So that was my thought process. I was just curious if you've done anything, because when you say like there's nothing like production,
yeah.
and I translate that as test in production.
Yeah, yeah.
Um,
Okay, so in that light, yes, we've done something like that. So this, did I show you the payments gateway we built?
I don't
That,
think so.
oh, okay. So let me show you. Just go to cyberpay.ng. Yeah, that was the payment platform that I essentially bled for before I left the company I used to work at. You know, um, yeah, I was so adamant to finishing this payment platform. It had like six. It's like a combination of 6 or 7 different services. So it's not just a monolith per se. You have the wallet, you have the settlement, and so on and so forth. And one of the ways we did that, and by law, by regulation, right, you have to have all these things in place. But the way the chaos engineering is done for the payment platform was that you, we had specialists, right? Essentially, there's a name they call them. Is it infosec or something like that? Their job is to try to, break the system by any means necessary, to hack you in any way they can, right? To try to sniff tokens, to try to push fake transactions, to try to, load your system and all kinds of things. So they were responsible for that. Granted, it's not chaos engineering like you have in Netflix, where they just let some bot loose in their data center and it just goes down, knocking down machines and scattering things. But at least it's the closest we got to being able to test the resilience of the platform. You get
Okay.
so just like it's human beings that did it in that case.
Yeah, because I plan on doing something very similar. Uh, I call this, you know what this type of development is called, Odie? It's
Which
called
one?
resume-driven development. That's what I'm doing right now. So
Uh,
yeah, I gotta put all that stuff in there.
I feel you. I feel you. But you should also consider like starting a business. Like starting some kind of business or online service, or an actual thing, like building an actual product that you hope people will use. And
Well,
all
what I
that.
demoed to you is something that I'm trying to build as a business, but
Okay.
it's really kind of like staged. So like that's like a beach delivery service.
Mm-hmm.
I live like on the beach in Miami, and
Yeah.
so like people don't. There's no services that I'm aware of that delivers groceries or restaurant meals to the beach. So
Mm.
that's what I've been working on for like the past maybe 3 months. And so the
Okay.
mobile client is pretty much done now.
Mm.
I literally like walk up to random people and toss on my phone, and ask them to place an order. And I've been getting a lot of feedback. A lot of it's made me feel very, very silly. But like, so I nailed all that down. So like, I want to set up a business where I buy like people can like get electric bikes with trailers on it, and they just run back and forth between the beach and grocery stores or restaurants. And that's what I'm trying to set up. But that's just the proof of concept that I still want to make it a business.
Okay.
What I wanted to prove out is the actual infrastructure that I'm building on the back end. So I want to use that as an example or a proof of concept, and then be able to serve like small and medium-sized businesses that need a request and deliver type infrastructure. So dry cleaners, restaurants, whoever can't afford, whoever doesn't have nor can afford to pay out big bucks to get that type of software that's similar to like Uber Eats or Postmates or any type of order something, and then you could track it being delivered, and you have like the bells and whistles of the maps and everything. You could call, message, figure out where they're at, or vice versa. I want to build all the infrastructure and just stamp out the same app, the same mobile application, or even like web application, and just change the skin to the branding of that particular company, and just have a subscription model that they pay like, I don't know, $100 or $200 a month, and they have their own mobile app or their own website where people place orders, and then they can track those orders, and they send notifications to those clients about where they're at within the stage of the order. So that's what I'm doing. It's just this beach delivery app is the proof of concept, and then refine it, and then license it. So.
Okay, so here's what I think you should do, right? There's no way that you are going to succeed out of the box, right? In terms of, I mean, like, there's no way you can build it without having some issues, right? On launch day, no amount of, someone used to say, no amount of planning can survive contact with the enemy. And for me, I rephrase that to say no amount of development can survive contact with the customer. You get, so it doesn't matter if you spend 4 years building it. The moment it lands into the customer hand, sparks will fly. So what you could do is to just get something out there. Let it, yes, it may not work out well initially, but that's fine. Let it use that feedback, the actual feedback of people actually using it to like reinforce your system. That said, I think I have something that should be of interest to you. It's called the 12-factor apps. I don't know if you know about it.
12-factor what?
12-factor apps.
Okay.
Right? Yeah, so it's a way of thinking about building, highly scalable systems, right? It's like 12 things you should always consider when you are building any kind of large scale application, whether it is
hold up, this may sound familiar. Is this written by some guy that has a whole bunch of businesses and he lives in like India or something, and he makes like $30,000 a month?
I don't remember. I don't know, but I just know about, I sent you the link, 12factor.net. So I've been hearing about it, and I've been studying it myself. So, but the main idea here is, I think it's 12 things, right, that you should consider when you are building DevOps in general. So think of your code base to track and manage one code base tracked in revision control, many deploys, explicitly declare and isolate dependencies, store configuration in the environment, treat backing services as attached resources, build, release, run, execute an app as a stateless process, expose services via port bindings, scale out via the process model. So there was scale out processes, as opposed to machines or something like that. Disposability, maximize robustness with fast startup and graceful shutdown. Dev/prod parity, what we just talked about. Keep staging, development, and production as similar as possible. Treat logs as event streams. admin processes, run management tasks as one of processes.
Oh, no, where
You know,
are you reading at? I don't. Where's? Oh,
yeah,
okay.
yeah,
I see it. Okay, never
yeah,
mind.
12factor.net. So the main idea here is if you have these things in mind, then you should be able to build very resilient apps that can scale and can grow and all that, because you are currently at the point, you as an individual, right? The coding is not really your problem. It's not really your challenge per se, because you already know how to write the code for such things. I think what is now necessary is how do I build, manage, and scale, those kind of services. You know, um, that's like the DevOps aspect of building applications, and that's probably what you should consider. There are talks and there are books on this 12-factor app, so if you have time, you can just quickly go through them and yeah.
This is just like a checklist. It's not going into detail for each bullet point,
Yes. So what I mean,
or is it? Hold on. What if I click on backing services? Oh, okay, never mind. All right, I'll take that back.
oh, okay, yeah, yeah. So, but even then, it's still, how do I put it? It's still vague because it's an idea that applies to any stack or any tool you're using or whatever the case may be. It's just things to keep in mind, right? When you're building out applications. And it's one of the reasons I kept recommending Kubernetes to you, was because Kubernetes actually solves a lot of these problems out of the box. So you don't even need to worry about it. And the challenge is learning it. Okay, so once you learn it, applying a lot of some of these things on top is actually straightforward. So remember, I was telling you about the Treble service I was building, right? And how setting it up was such a pain. But after I was able to set it up, it works perfectly well. So, for example, adding SSL certificates to applications used to be a pain for me. Um, Not that I didn't know how to do it, but going to IIS, buying the certificates, encrypting it, going to IIS, setting it up, attaching it to the domain name, and having to repeat that for every domain every year was just a pain. So, but with Kubernetes recently, I just discovered that because of the way it's structured, you can easily just install something called an ingress controller, and then it can do all of that management for you. So it can go ahead and get SSL certificates and configure the SSL certificates for you, so that way you never have to worry about it ever again. And trust me, as someone who had to manage like services for close to was it close to 4 years or close to 6 years, that was like a godsend.
Mm.
So yeah.
I only did that like once or twice, and I had no clue what I was doing. I was just following Stack Overflow.
Yeah, so you just need to do it more and get more experience, if you ask me. But yeah.
How's your app doing? Are you finding time to work on it? Your hobby project?
Yeah, so I can just send you the URL. That's I don't know if I think I had sent it before, trouble.io.
Oh, by the
Um,
way, that CyberPay, like
hmm,
the user interface looks really nice, man.
yeah.
Do you know who actually did the UX for it?
Yes. It was a company called Credital, a Nigerian company. They do like really good designs. So we just hired them to help us do the branding. So what they do for you is they what exactly they do for you is you communicate your vision to them, you tell them what colors you like, and stuff like that. Then they will walk you through it. They will say, okay, you are into payment, so you should look at more primary colors, or you are into entertainment, so you should look at more fun colors, and they would suggest to you and they would help you come up with the logo and design the logo and design the website as well that will go with the logo. So they do everything at once. So if you remember Nigawela, right? It's the same thing. So if you go to nigawela.com, they were the ones that did that as well. So even the logos and all those stuff as well were done by Credital. They're really good. So yeah, Yeah, that's what. Yeah.
I'm sure that I'm sure it probably takes mid to large size business to pay for their services, and not just someone like me.
Yeah, yeah. We paid. Let me see. I don't know if they would appreciate me
They charge
exposing
by the
them.
hour, or they charge for an overall project.
No, they charge for the overall project. So let me see. This is paid close to 2 million naira. Let's see, 2 million in USD. That is $5,500.
Okay.
Yeah, yeah. So it's not cheap, but their work speaks for itself. It's really good. You
Yeah.
know. So yeah.
Cool. Oh yeah, I was asking about your hobby project.
Oh yeah. So that's Treble.io. I'm still yet to do the identity server aspect. So there's some authentication that needs to happen. So, but I'm yet to set all of that up. So if you've seen the link, right? So if you
Yeah.
click it, it just takes you to a safe stack application, which is just,
Well, it wants me to log in.
yeah, that login isn't working just yet. It's just, like a template or something. But I plan to flesh it out in the coming weeks. Then also, speaking of fleshing things out in the coming weeks, if you notice, I bought new gear, so I have a new mic. I don't know if my mic sounds really good. Does it sound better?
Oh, it sounds fine.
Okay, okay. So the yeah,
It's picking up the background noise very well.
exactly. Hold on, I'll be right back. All right, better now.
Yeah.
Oh, okay. So yeah, I plan to start recording videos again. It's like almost for a whole year I've been totally off. No blog posts, no videos, nothing.
I
Yeah,
mean, you started working for a fintech, or you started working for some European company, right?
yeah. For Edelweiss Connect, and in fact, I was in Switzerland last week for like close to 2 or 3 weeks.
Oh
I was in
wow.
Switzerland. Yeah. Then I went to Slovenia. I took loads of pictures. Met with the rest of the team. It was fun.
You don't
Lots
want to
and
move
lots.
out there?
Switzerland is super expensive. I plan to eventually, but things there are really, really expensive.
I'm sure
But
they'll update your cost of living.
yeah, sure. But my plan, so I'm just looking at maybe next year, maybe early next year is when I'll start working towards moving. But in the meantime, I'm just enjoying, going there for like a vacation and stuff like that because I'm still going back there again. Sometime in September, October. Let's say ending of September, beginning of October. I'll still go again for like 2, 3 weeks and then come back.
Odie, man, you need to tap into some U.S. wages, man.
Of course, I've come. It's just that I don't know, like the wages there are pretty good. Trust me, like it's almost double what I was earning before. But what I really like about this, company I currently work for is that I do everything remotely. So I don't have to like wake up like a 9 to 5. I can choose when I want to work, and I can work on other things in my spare time. And the people I work with are also very good as well, and we use F Sharp exclusively. So for me, those three combinations are like a very powerful trifecta. I don't have to wake up, 9 a.m. in the morning to be dressing up and going to work. That's the first part. Second part is, the pay is really good. And the third is that it's pure F sharp. right? And I'm with like-minded people who like F sharp like just as much as I do. So
Is there any syntactical or anything specific to F sharp that you learned since you've been working over there?
oh yeah, lots and lots of things. So
Okay.
I learned how to use F sharp for client side development. So using Fable, even the quirks,
Oh, yeah, yeah.
yeah, the quirks around Fable, understanding like and seeing the advantage that Fable gives you over something like using Angular JS or things like that. The whole Elmish architecture as well. I learned that. I also learned how to use. There was this library that's really good. Let me see if I can find it. It's called the CVDM error handling, but it has been changed to. Let me see. Just because I know you will like this library. Let me see if I can find the exact name. Yeah, it used to be CVDM error handling, but it has been changed to FS Toolkit error handling. So what it does is really super cool. So I'm sending you the link. What it really does is that it essentially has a way of encoding side effects. So you if you have something that is a side effect, it's probably async. It should be async first and foremost. And secondly, is that it should not throw exception. It should return like a result of success or failure, right? So what they did was by encoding async result as the thing to handle side effect, they now have like computation expressions that wrap async result with the necessary monad methods and so on and so forth. So that makes it really a really nice way of dealing with side effects in your program because now anything that talks to the outside world doesn't just return string, it will return an async result of string. Does that make sense?
Yeah, yeah. I mean, that's what I was doing with the app that I'm building.
Yeah.
Anything that this is kind of where like I was able to develop somewhat of an appreciation for category theory
Mm,
because it how do I say this? For everything that was returning for any of my functions that relied on IO,
mhm,
I would create function type signatures for them to implement, and they
mhm,
would return a result type, hence OK or error. But then,
mhm,
and that was fine because I always do like the database side as a second stage. I create like a in-memory database whenever I'm building a new application, and I
mm,
just mock out as if I was going outside of the process
mhm,
of hitting a database, but I'm not. I'm just impersonating it. But
mhm,
then, like once I reach the latter stage of okay, I really need to like build out a database and connect to it.
mm,
Then I realized that yeah, all these function type signatures that I built that ultimately return a result
mm.
of something, that's not going to work because I really am relying on IO now, and so it needs to return an async result.
Exactly.
But but logically, I shouldn't have to. If I'm doing like type level programming, if I'm doing type
Mhm,
level programming,
mhm,
then having everything, having all my functions that do IO have to specify that this is asynchronous. Asynchronous is like an implementation detail. So like I feel like that's kind of like a leaky abstraction. And so
Uh,
that's when I
not
started. Well,
that. So not you are correct, but not quite. Because if you think of IO, if you really think of IO, right? IO is asynchronous. Do you understand? All IO is asynchronous.
it
So
is, but logically, I didn't mean to cut you off. It is, but when I'm
mhm,
domain modeling,
yes.
should my domain model really care or acknowledge or understand the the complications between
Oh, I
communication
get
between
it.
servers, and it shouldn't. It shouldn't.
Oh,
It should
okay.
think that everything. It should really believe that everything is instantaneous, and it should not. It should not know about reality. All that should be
Okay.
abstracted away. And so that's where I was
Okay.
saying category
Okay.
theory started coming up.
No,
So now you're leveraging
no, no. There's a
generics,
there's
and
a solution to this your problem. Yeah, just give me a moment. I think there's a talk by Mark Seaman. I don't know if you've seen it. That has async that explains this exact problem that you're talking about. I think it was in the last NDC that he talked about it. So what happens is that the reason why your domain, it seems as though your domain is needing to know about async is because your domain actually is mixed with IO operations, which it should not be, right? So the way he explained it was that if you think of every program as inputs and outputs, right? Then you should have IO coming in, then some layer that is totally pure, then IO going out, right? So what should happen is you should have like 3 layers, right? At the entry point of your application, there should be 3 layers. There should be the IO layer at the top, and there should be a domain layer in between, then the IO layer, which is the output at the bottom.
the data
So
gateway or whatever.
yeah, exactly. So for the layers on top and at the bottom, right, you would have just yes, you can still have async in the signature, but what should happen is that you should how did he explain it? You should the main your domain logic itself should be pure, meaning that it doesn't have anything like IO in it, right? Then you would now like layer using async results.bind using bind functions or map functions or things like that. You would now transform the input through your domain layer to the output. It's really difficult to explain, so I'll try my best to just send you the link. You watch the video, then I think it will make a lot of sense. But
There's another alternative to that is you make your function type signatures generic. So like this is where I was saying that I started to have a better understanding of category theory, just a little bit better, when you're able to take your function signatures and you massage them or refine them into from like a dozen different function types to like 3 or 4, because they all have the same type of signature, or they all share like maybe various sets of signatures where you can inject. If you take advantage of generics in F#, you're specifying that. I wish I could show you a code example, but I don't know. The last project that I did was proprietary. You're basically injecting the types that you're going to be using or returning. So you're injecting a sync type that your generic function is going to rely on, right? But it could be anything. I'll have to show you an example later.
No,
but you're making your functions in generic. That's all I can say. And then your consumers of those functions are going to provide the
specific
concrete types.
Yes.
And that's how I got around it, while still maintaining a very abstract function type that had no clue about async or anything like that. But my clients did, because my clients needed to interact with specific APIs that would only return a asynchronous result.
Of course. So again, like I said earlier, right? There's a little bit of that going on. So I wish you could maybe click the link and check it out. The name of the talk is Async Injection by Maxime. He precisely answers this question that you raised directly. Okay. Explaining why, because he used C# to explain it, because if you think of C#, right, the moment you have like a task of int, right, immediately, everything you do has to be await or async as well. So async tends to spread throughout the system. So he pointed that out and also now explained why you should still have your domain set pure in quotes, and then layer the async abstraction on top of it. Because if you think about, your business logic, if your business domain is pure, if it doesn't deal with any input whatsoever, then it shouldn't matter whether you are running it. Because what async means is, I'm going to run this thing later. That's all async means. Okay, meaning that you're going to get the result later. Now, if the computation is pure, it doesn't matter whether you are running it now, or you're running it, or you ran it yesterday, or you're running it tomorrow, right? The result is still going to be the same. Does that make any sense?
I understand what you're saying.
So
I kind of disagree with the results going to be the same.
Okay,
Because it's
let me
not.
give you an example.
A side effect isn't guaranteed to be the same.
No, let me
It's
give
not
you an
pure.
example.
Or
let me give you an example. Let's say your business
Deterministic.
logic. No, I'm saying business logic, right?
Okay.
Let's say your business logic is calculating the total items in a cart, for example, right?
Okay.
It doesn't matter whether the items in the cart are coming from the database now, whether it's coming from memory now, or whether it's coming from the database later.
Exactly.
The addition is going to be the same every single time, right? So if you separated your addition as a domain logic into a separate module, it doesn't have to take an async list. Do you get what I'm saying?
Mm-hmm.
It just needs to know, I take a list and I'll tell you the sum, and that's it. So what now needs to happen is your UI now needs to layer on top. Okay, I pull out data from the database, it's async. Then I will now use something like async.map, right? And then supply the list, okay, and supply the business logic, essentially. Async.map, supply the business logic, and I will get another async back of whatever is the solution. You get what I mean?
Okay.
That layer is what Maxima was talking about. So if your business logic is pure, then it doesn't matter how the inputs come, right? You will still be able to apply your using function application or pipelines or whatever, apply the business logic on top. Does that make any sense?
It does at a high level. I'll have to see
Where the problem comes is if your addition function has to talk to the database, and then everything breaks down at that point. You get. So that's the thing.
Yeah, man. What's crazy is 5 years ago, I would never think I would be able to have these types of conversations and know either understand it or contribute to it. It's crazy how much I evolved.
Yeah,
really since I started picking up F Sharp, man. I really attracted a different set of people to exchange ideas with and ask questions to. So it's cool.
Yeah, me too. So, yeah, Scott, I don't know if you still have time, but I wanted to. There's someone I was supposed to meet outside today around like 9:30. So
hey, no worries.
But it was really fun talking. I would like us to do this again sometime. Maybe after I release one of my videos, because there's a video I've had in mind to do, but I've not really, gotten around to do it. Like, I wanted to teach how to do scripting in F Sharp from scratch for absolute beginners, for people who have never even coded before, right? Just to be able to install VS Code, then to use F Sharp script files, and then using Packet with F Sharp script files. That whole workflow. So
you know who you could probably talk to, because he wants to build courses for C# developers to transition them or migrate them to F#.
Okay.
Is what's Sam's last name? Sam Williams. I actually tagged you one time saying that meet Sam Williams or whatever. He lives in what's the country outside of Australia?
New Zealand.
He lives in New Zealand. He's a razor sharp dude, and he's trying to he's actually building a product to help C# developers, C# mobile developers build F# mobile applications. So he's been focused on building out tutorials and video courses on Fabulous. I don't know too much about it, but that's his Twitter tag right there. I'll make another introduction. But it seems like you
Alright.
guys have more in common based on the project that you want to do. I'm
Yeah.
still open to it. It's just I feel like he probably can
Mm.
provide more insight or help or feedback since you
Yeah.
guys are somewhat going in a certain path together.
Mm. Okay. Yeah. Yeah. I think I'm already following him. So yeah, makes sense.
Yeah,
Makes
I
sense.
think I had a session with him like I'm doing with you right now. It's been about
Mm.
maybe 5 weeks ago. I need to catch up with him again.
Okay.
But
Okay. Good.
yeah, good stuff. Oh, I didn't mean to hold you up. All right. Yeah, let me know the
Yeah.
next time you want to hang out. And I really appreciate your consultation. You can send me the invoice, and we'll catch up.
Nah. Nah. It's good. It's good. Yeah.
Yeah.
All
All right,
right.
Odie. So I'm gonna stop broadcasting. I'm gonna go work out or something. So we'll
All
catch up.
right.
See ya. Thanks. Bye.